Hey y'all! In this video, I'm going to answer a question that I got in my live Q&A number 2. Now, if you've not caught any of my live Q&A videos, after I release a video on Sunday morning, I go live at noon Pacific, 3 Eastern, and we discuss the topic that was included in the video that went live earlier that day. If you didn't catch live Q&A number 2, I'll put a link to it in a card up above here right about now. Now, the question came about why it seems like the VCarve software or the Aspire software, after you've saved G-code and you're outside running it on the machine, it appears that the bit just kind of hopscotches around. And is there a way to kind of smooth things out and maybe speed up machine time? So I'm going to get into that today. There are some things we can do to kind of mitigate some of that, but overall, in general, when calculating toolpaths, the software tries to optimize, meaning it tries to figure out, based on your home position, in this case with me, my X0, Y0 is down here in the bottom left corner. It tries to optimize it so when the bit is actually retracted up out of the material, it does that as little as possible. Now, obviously, in this demonstration here, where I have 4 rows of 7 rectangles, it's going to have to lift up out of the material and move over to carve the next rectangle, whether I'm pocketing these out or if I'm cutting out individual rectangles. But other times, as in the case of the 3D sign that I cut before, when we look at the toolpaths, we have a 3D roughing toolpath. When we get into the 3D view, we can see the red lines in the illustrated toolpath. These are all rapid moves. The blue lines are plunge moves. The green lines are retract moves. And we can see they're willy-nilly all over the place. What the software attempts to do is start from the home position and move over to the closest starting point and start carving, in this case, in a raster pattern back and forth. It will then get to a certain point, lift up, and move over to another area. For instance, in this case, it carves away a good portion of what's down here, then lifts up and moves up above and starts carving back down this direction. There doesn't seem to be any real rhyme or reason to this. And in a 3D toolpath, there's not a lot you can do. You don't have much control over how the software decides where it's going to cut and when it's going to cut it. We can double-click the toolpath to go in over here and take a look, and there's no real way to choose where it's going to start, where it's going to stop. It's going to kind of make up its own mind when it's going to cut what. Down here where it says manual vector selection manual, this area down here is mainly to associate that layer with the toolpath. So this doesn't really help you to decide what it's going to cut or when it's going to cut it. Now that's in a 3D toolpath. If we go back to our rectangles, when it comes to cutting a pocket or cutting a profile, we do have a little bit more leeway. We have a little bit more control over what's going to cut when. Let me start by selecting all of these vectors here and making sure all of these vectors are within my box. Let go, and they're all selected. Now let's come over here and do a pocket toolpath. Now I'm going to ignore everything up here right now until we get down here to use vector selection order. If we check this box, what's going to happen is, in this pocket toolpath, the software is going to look at what order I selected these vectors in and apply the toolpath appropriately. So basically, since I started down here and selected up to the top, that's the way the software is going to attempt to calculate the toolpaths. We'll calculate, and we see that's exactly what happened. We have our rapid moves here. Let me scoot in and zoom over, and we can see we have a lot of rapid moves in red, a plunge here in light blue, and then a bunch of retracts in green. Now we can kind of see how it's going to do that by previewing. Now if we look at the clearing toolpath and get rid of the cleanup toolpath and just look at how it's going to come in and clear all this out, we can see exactly what's going to happen and how it's going to machine this pocket by coming up here under Preview Selected Toolpath to this button right here. And you see how that little bubble pops up and it says Run to Retract. What that's going to do is it's going to run this toolpath from this plunge point to the next point where the bit will retract. So I'll go ahead and I'll click that, and we see it carved out most of that pocket. Now I'll do it again and it will run to the next retract point. And that's where it did its profile to come and clean up these rough edges where the bit went back and forth. Now we'll go to the next retract. We see it moved up to this next box here. I'll do it again, and we see it did its profile. Now I can go ahead and run the entire toolpath just by hitting the play button here, the run button, and we see it's going to go ahead and finish it up. But now we see the order in which it's going to move. I'll come back for a straight Z shot, and I'll turn on the visibility of the toolpath by clicking in the check mark here. And we see by looking at these red lines, it's going to rough out this one, then move up to this one, up to this one, up to this one, then come over and go back down. That'll work for us. But let me reset the preview, and I'm going to try a different order. What I'll do is I will draw a box around these rectangles on the bottom, hold down Shift, and then select these. Still holding down Shift, I'll come back and I'll select this row, then this row. Now, if I close my preview and go into Pocket, I'll change nothing else up here, but I'll click on Use Vector Selection Order. Now I selected this row first, this row second, third, fourth. It should calculate a toolpath to run all of these first, then come back and either start here and run this direction, or it'll lift up and come back this way. The software knows to take the shortest route possible. Let's see if it does so. And it doesn't. It's going to lift up, come over, carve this one, move down the line till it gets to the last one, then come back and start here. then come back and start here. Close that, we'll come back. Now I'll select them one at a time. Okay, I started this way, went down the line here, up here, over. Let's do another pocket toolpath. Use vector selection order, and we'll calculate that. And we see that now instead of getting to this end of the line and running all the way back here, it just jumps up to the next one. So let me preview that just to make sure. And it's machining out the way we expected it to machine out. Now, you may be wondering why I'm even talking about this. Let's check it out and we'll see. Now, I'm just going to use the pocket clear for just a moment here. We'll select all three of them and we'll come up here to Toolpath Summary. And we can see that they each one have a different time. Pocket 1 we did with no modifications. We didn't use vector selection order at all. We let the software decide where it was going to go, in which case it was running up and down and coming back and forth this way. And that has the shortest machine time of 7 minutes 39 seconds. We then, for Pocket 2, went left to right, and it was running along this way, lifting up, coming back up here, and going this direction. That gave us a running time of 7:54. I then came back and went this way, had it come up here to cut this way, and back over here to cut this way. And we see we have the shortest machining time of 7:36, but it's only shorter by 3 seconds. So let's go ahead and turn those off. Look at our finishing toolpaths. Pocket 1 is shortest by about 3 seconds. So, basically, letting the software decide where it wants to go, when it wants to cut there, is the way to go. That's going to give us a total of 1242. This one, 1329. And this one, 1305. So it doesn't save a lot of time, but if you're in a production environment, time is money. In this case, on something like this, letting the software decide where it's going to cut and when would be most advantageous to us. Now that's for pocketing. Now when it comes to profiling, there are some other considerations because we have a few more options. So let me go ahead and select all of my rectangles here, and we'll do a profile toolpath. Now, right off the bat down here, we don't see anything about use vector selection order, but if we come down here, there's an order tab right here, and we get a lot of options. We can choose the vector selection order, which is in which order did I select each of these rectangles. We can choose to run from left to right. We can choose to run from bottom to top. We can choose to use a grid, or we can choose to allow the software to take the shortest path. And we can do this by checking or unchecking these boxes, and we can check more than one. Now, you may be wondering why I'm even discussing this when it comes to profiling. This is a small project, and I'm cutting a small series of rectangles here. But if you were in a production environment and you needed to cut all these rectangles, You could technically set your vector selection order to go from left to right, bottom to top, and as soon as this rectangle is cut, you can pull it off the machine and start finish sanding while this is being cut. This just allows you to select which way your axes are going to move so that you can remove parts and move them on to the next step in the process while it's finishing up the cuts on the rest of these parts. Now let's go ahead and take left to right, bottom to top, and calculate that and see what we get. We can see here we have a rapid move that comes this way. Scoot it up a little bit. There's the plunge and retract on the same corner. And the same thing here, a plunge and retract, a plunge and retract. And it's going to move down this direction here from left to right, then move up, bottom to top. Come back this direction, come back this direction, and cut all of them out, giving us time to grab this one and move it along to the next part of the process while this one's cutting, and so on and so on. That's why some of this stuff matters. It's machine times as well as convenience for you. If we look at this here, our estimated machine time is about 3 minutes, 16 seconds. These are small parts, and it's a small piece of material. There's not a lot of savings worth really going after when we're talking 3 minutes and 16 seconds. Now, if you project this up to a full sheet of plywood and you're cutting out drawer fronts or cabinet sides or something of that effect, it could mean a big difference. And the ability to cut out a part here, a cabinet side for example, and pull that out and get it along to the next process, maybe edge banding or sanding or what have you, while it's cutting out a cabinet bottom, that would be advantageous to you. So for something this small, there's not really a lot of time savings to be had by adjusting whether we use the vector selection order. Let's go ahead and try that. Calculate, and we'll close that. Now we'll look at it. It went from 3 minutes 16 to 3 minutes 29, so it added 13 seconds. You're going to spend more time walking over and picking the material up off of the table than you're going to save. So there's not much saving to be had here, really. So we'll go ahead and we'll close that up. Just know that out of all of the toolpaths, when it comes to your vector order, you have the most control when it comes to which order the toolpath is going to run. You have the most control in a 2D profile toolpath. We'll close that, and I'll get into another situation where we're talking about Vee carving. Now in Vee carving, there is some savings to be had. I've run 3 or 4 different toolpaths here to demonstrate what I'm talking about. We can turn on the visibility and you can see that they're all basically the same thing. It's just the order in which the vectors are selected, plus a couple of other factors. This VCarve here, I'll turn it on. It's just a simple straight rectangle. There is no selection order. It's a single part. It doesn't matter. So I only ran one to simulate. But if we go over here into our preview window and we select number 1, we look at our movements here, we can see that the bit is going to start from the home position, come over and start cutting the S, lift up, go to the I, but then it's going to jump up here to the U, the C, the T, this T, the A, and come back around and do it basically in a circle and kind of hopscotch around a little bit. But if we turn off number 1 turn on number 2, we see it starts down here on this corner instead of up here, and it moves around again just wherever it wants to go. It finishes down here, lifts up and comes up to do the C, then the T, then the T, then the A, and then comes down, does its thing down here, then comes back up. We'll turn that one off, come up here for this one, and in this one it goes up here and starts cutting up here. It does cut the entire line of text, then comes back down to the S and then goes over this way, then comes up. Now I'm going to show you what each one of these represents. So we'll start here with this one, number 1. I will double click on the VCarve toolpath, and we see here I'm not using vector start points and I'm not using vector selection order. This is how the software decides it's going to cut it itself. We'll close that one, turn that off, turn the visibility on this one, and we see this toolpath, I'm using the vector start points. What I mean by the vector start points is, turn that visibility off, we'll come back over here. All of this text has been converted to curves. And when you convert to curves, it's no longer a text object, it's a regular vector. And as you know, every vector has a start point. Now, what I'll do, I'll come back over here into my drawing tab and I'll need to ungroup everything. So we ungroup, and we'll start down here since our start position is down here. I'll ungroup these and we see we have separate vectors. Now if I go into node editing by typing the letter N, I can click on this vector and we see the start point is down here in the corner. The bit is going to lift up to go cut this S, and that's where it's going to start the cut, at the start point. Same with the I. Same with the L. Same with the V. It's going to use those vector start points. But now we get up here into the letter R, and there's a start point up here. That'll become relevant a little bit later on. The inside of the R, it's right there. Go up to the D, it's down in the bottom corner. The U is fine. U is up here in the top corner. And the C, it's over here. So there doesn't really seem to be any rhyme or reason as to where the start points are. This will become relevant a little bit later. So right now I'm going to tap the letter N to come out of node editing, and I'm going to undo all of that ungrouping. So we'll come up here to Edit, Undo Ungroup Vectors, Edit, Undo Ungroup Vectors, and that was the last edit I made to this file. I can't undo anything else. So now when I select that, they are all regrouped. And my toolpath is just fine. Now we'll come over here and we'll take a look at this toolpath. And I'll double click it, and we see Use Vector Selection Order has been selected. So evidently, by surrounding all of the text to select it, the software has decided that the best way to machine it using that vector selection order is to come up here and start with the D. We'll close that, turn off the visibility there, turn on the visibility here, and I've selected both. Use vector start points and use vector selection order. So it's going to take both of those things into account, and as we see, we had the start point here on the S down in the bottom corner, and the same with the I, same with the L, same with the V, same with the E, but then it gets up here into the R. That's when things changed. And up here we have the C on this corner here. We have the U up here. This is where things changed, and the start points didn't actually make any sense. Like, why would we have a start point up here on the E? It should be down at the bottom corner. So using both the selection order and the vector start points, it had to calculate our toolpath taking both of these into consideration. Now, let's select all 4 of these and take a look at our toolpath summary and see which one is going to take the longest to run. Now, this is highlighted in bold because that's the toolpath I have selected down here. I could just as easily click on number 1 and you see that comes up in bold. But if we look at all of these toolpaths, even though they're all going to take less than 4 minutes, number 2 here seems to be the shortest run time, 3 minutes 48. Now 3 minutes 48 seconds may not seem like a whole heck of a lot, but if you're in a production environment or you're carving 15 of these, time is money. So let's go back and take a look at which one that is. We'll shut off the visibility to all of those, turn on the visibility to that one, and we'll go in using vector start points was the most efficient use of our time. So changing this from the way the software had decided was the most efficient use of time to using the vector start points is beneficial to us. Well, now knowing that, maybe we should get in and change these start points to where it's something a little bit more realistic. So let's see if we can save any time by doing that. We'll close this. We're going to remember we want to use vector start points. I'll go back over to my 2D view. And again, I'll ungroup everything. Then ungroup it again. Then we'll come back over here, go into node editing. The E is okay. The R, let's move the start point from here down to here. Make start point. That's already okay. Let's go over here to the D. Start point is fine there. And it's fine there. The U, this makes no sense. Let's start it right here. Make start point. Same with the C. Let's go from the top corner to right here. Make start point. And same with the T. I'm going to go through each letter and change the start point to something a little bit more realistic in that the cut will end here on this C. Let's let it retract out of the material and come over and start cutting this T down here in the bottom corner. I'm going to go through and do that on all of the lettering. Okay, with my start points changed, I now want to go ahead and regroup all these. I'm going to regroup this section of text into one group. I'm going to make this section of text another group. Then I'm going to group them all. That way I can come in and edit one thing, one section, without affecting the other. So let's go over here and we'll recalculate this one using vector start points. We'll calculate that toolpath. We see there's a little bit more logic to the way it's going to run. Now we're down to 3 minutes 46. So doing all of that only really saved a couple of seconds. But again, if you have 20 or 30 of these to run, it can make a difference. I'm going to go ahead and end this right here. Basically, it's all about vector selection order and how much or how little control you have over it. Generally speaking, the software tries to create the most efficient toolpaths with as few plunges and retracts to try to keep the bit in the material cutting rather than lifting out of the material and moving. And oftentimes what we think is a waste of time, why doesn't it just plunge in and cut the whole thing and cut this whole line here? Well, a lot of times it's more efficient to cut these three, jump up and do these two, then come back and grab this, then go down here. It sounds counterintuitive. It sounds funky to us. But by looking and comparing all of the toolpaths, we can see that sometimes there is some time to be saved by creating our own toolpath order or our own vector selection order, but more often than not, there really isn't. It just depends on what you're doing. And this is another reason to pay attention when you get into node editing. Pay attention to where your start point is. If I select this outline, type N to go into node editing, my start point is way up here, when my home position is down here. So technically this should be a start point here, because there's no sense in this bit lifting up from here, going all the way up there in a rapid move, plunge in, and then start cutting. Makes more sense for the bit to lift up from here, move right there, then cut. It's going to start and stop on this point. It only saves a couple of seconds, but again, time is money. I hope you got something out of this video, and I hope it didn't just confuse you like crazy with all this. I will be hosting a live Q&A this afternoon on the day this video goes live at noon Pacific, 3 p.m. Eastern. I'll be doing a live Q&A to answer your questions on vector selection order and trying to save machining time by trying different strategies to see which one would be better for you. I do hope you'll join me for that live Q&A. I'll take your questions and try to answer them right there live. Come and join us. We have a lot of fun. There's a live chat. You can get your questions to me right then and there. So again, I hope you got something out of this video. If you did, please consider giving me a thumbs up. And if you'd like to follow along with my further CNC adventures or keep abreast of the Vectric for the Absolute Beginner series, I do hope you'll subscribe to my channel. If you're subscribed to my channel, click that little notification bell button right next to the subscribe button. Then you'll get a notification when I post a video and when I go live for our live Q&A sessions. As always, whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch, and y'all take care.